Hello everyone, good morning and welcome again to one of our online sessions in science. Today is Sunday, March 29. How was your weekend? Great, that is great. So today we're going to learn some new things. Some of them are just recall of what we did and just more of the analysis of what we did in the previous chemical reaction. So if you have your course book, pen and notes with you, let's start with these questions. Question number 1. The abundant gas that is diffused to the soil when there's a lightning, which is really good for plants like peanuts. The correct answer is nitrogen. Did you get it correctly? Nice. Next question. A vegetable that can be used as an indicator if a solution is acid or base. Time is up. Let's see. It's cabbage. Did you get it correctly? Nice. Next question. It's a type of metal that can melt in a hand because of its very low melting point. You have the clue here. The symbol is Ga and it's number 31 in the periodic table. The correct answer here is gallium. How much marks did you get? Did you get 3? That's awesome. So please write your mark on the chat box, or you can just message me your mark so that I can record it. So what do you think our topic for today? Our topic for today is all about detecting chemical reactions. So when you see the word detecting, what comes into your mind? Very good. That means that we are analyzing or we are determining what makes the chemical reaction. So it's found in course book pages 118 and 119 for your references. So we're going to learn today the following. Analyze the different indicators that a chemical change has occurred and investigate the type of indicator used to determine a chemical reaction. So we are talking about here indicator. So what is an indicator? Very good. An indicator means that something will identify if a chemical reaction takes place. So, as an introduction, in a chemical reaction, there are new products which are formed. For every reactant that we have here, we have a very familiar chemical reaction that we have discussed previously. So, what are our reactants here? Clue, there are 2 reactants here. Exactly. These are the hydrochloric acid and magnesium. So if we react these 2 reactants, what is the product? Very good. It is magnesium chloride. So we have reactants that are formed in here. So going into these pictures, talking about chemical reactions, which of the following here you think is a chemical reaction? Think. You have the answer? The correct answer here is A, C, and E. B and D are just changed in the state of matter from solid, this one becomes gas. We call this process as sublimation, and this one is simply melting. So, give me one word that makes you think that these 3 pictures here are chemical reactions. 1. Fire is involved. So if there's fire, heat is also involved. That's why it produces a new product. There's change in properties because it's a chemical reaction. Therefore, chemical change is observed in this process. Gas is formed. For example, in this picture, usually it can be carbon dioxide or hydrogen. and a new product, just like magnesium chloride in our previous slide. That's the one which is produced. So I'm going to give you here 5 scenarios and 5 indicators that a chemical reaction took place. Let's take a look here with what is a chemical reaction first. So to define a chemical reaction, it is a process by which one or more substances called the reactants, there can be 2 or 3 depending on the chemical reactions, and they always produce one or more substances, and we call them now your products. In our previous example, we have magnesium plus hydrochloric acid. These are your reactants, and your product here is magnesium chloride. And what is produced? We will be producing hydrogen gas in that process. Please recall our previous lesson before. So we have here the evidences of a chemical reaction. So we're going to take a look with all of this. We have actually here 5. So let's take a look here with chemical reaction number 1. In chemical reaction number 1, we react here. Our reactants here are the copper oxide plus sulfuric acid. So when we add copper oxide plus sulfuric acid here is the colorless liquid, and the copper oxide here is the darker color here. So when we heat them, they form into a light blue color. So this one now, this one now is your copper. So the new product that is formed here now is your copper sulfate plus water. And notice that the water, the copper sulfate that we have formed here turns into light blue. So what indicator is used to determine that chemical reaction occurs? You have the answer? Let's see. The correct answer here is color change. From the dark color, it becomes light blue in color. Very good. Number 2, chemical reaction. I have here hydrochloric acid plus magnesium. So recall our lesson about metal plus acid. So what we are forming here is magnesium, and we're going to get something from the hydrochloric acid, and that is chloride. Plus it will release hydrogen gas in this process. So chemical reaction takes place here. So the question here is, what do you think is the indicator used to determine that a chemical reaction takes place? You have the answer? Let's see. Look at the picture here. Gas is given off. So what do you think is the gas given off in here? Exactly. That is your hydrogen gas. So if there's a gas formation, there's a color change form in a chemical reaction, it is a chemical reaction. Let's take a look with chemical reaction number 3. I have here potassium, and I put the potassium in a beaker of water. So if I put it there, the chemical reaction produces so much heat that the gas here tends to burn. So we are forming here potassium plus, and formed in here is potassium hydroxide. Why hydroxide? Because your water contains OH plus hydrogen gas. So you have 2H here, 1H goes here, 1H goes in here, and 1 oxygen goes in the hydroxide. So therefore the product here is potassium hydroxide plus hydrogen. So what do you think is the indicator which is used to determine that chemical reaction occurs other than the production of gas? What? Did you answer heat? Let's see. Heat is produced. So if there's heat which is involved, a chemical reaction is taking place. Very good. Let's take a look with our chemical reaction number 4. So let me just explain what's happening in this picture. or in this video. So this one is an acid. It's a hydrochloric acid, and I put a universal indicator in here. So a universal indicator changes the color to determine whether it's an acid or base. This one, however, is a base. It's a sodium hydroxide. So see the difference in the color. So usually your acid has a pH. What's a pH? A pH is a measure of the acidity or alkalinity of a solution. This one is 3. This one is 14. Is 11, I mean. But if you combine them, take a look with the color, and the resulting pH now becomes 7. So we call this process as neutralization reaction. So what is a neutralization reaction? It is used to balance or neutralize an alkali. Here, an alkali is your sodium hydroxide. If you add the acid on it, it changes the pH. This one has a pH of 3. This one has a pH of 11. But the resulting product that we have here is, it's water plus sodium chloride. So our product here contains the water, and this water here is said to be neutral because the pH is 7. So I want you to take note of this. If the pH is 7, it's neutral. It's neither acid or base. But if the number is less than 7, it is an acid. And if the number is more than 7, it's base. On this process, when we add the sodium hydroxide and the hydrochloric acid, an acid and a base, what happens is they tend to have a pH of 7. We call this process as neutralization reaction. So in the combination of that, there's also change in color, but the pH is the most important here. It changes to 7. So my question here is, what indicator is used to determine that a chemical reaction is taking place in here? You have the answer? The correct answer here is a change in pH. So again, if I combine the acid here with the base in here, so sodium hydroxide, and the hydrochloric acid, what pH did I achieve? Exactly, it's pH of 7. Very good. And it is neutral. The process is called neutralization reaction. Very good. Next, this is chemical reaction number 5. I have here silver nitrate. I have here 2 examples, this one and this one. Let's take a look here with this first. In this process, we react here silver nitrate plus calcium chloride. So the resulting product that we have here is silver chloride plus calcium nitrate. Okay, so what is formed in this process is this white thing here. So what is this? We call this one now as the precipitate. So what is a precipitate? Precipitate is insoluble. Insoluble means that we cannot dissolve them. That is formed when the silver nitrate is mixed with the calcium chloride. So take note, a precipitate will form here. That means that there is now a chemical reaction. So the whitish thing actually here is called your silver chloride. Next, are you familiar with this video right over here? Very good. This is now the use of your lime water to test for the carbon dioxide. And can you recall what is the chemical formula of the lime water? Very good. It's calcium hydroxide plus carbon dioxide. So what we are forming here is now your calcium carbonate plus water. So the precipitate here is in the form of calcium carbonate. So the question here is, what indicator is used in this process? Precipitate is formed. So we have here 5 indicators that the chemical reaction takes place.